Normally, when I start a talk on Salt, I will ask who has heard of Salt before.
This stuff you put on your food?
But I believe it's been somewhat difficult to avoid this week. And so I will only thank the SUSE people yet again for the wonderful support and partnership which we have enjoyed with them with respect to SALT. So, before getting started, in case anyone is unfamiliar with who I am or my association with SALT, I am the original creator and still chief architect of SALT. So I wrote it, it was my idea, and whether that merits praise or blame, enjoy yourselves. So my name is Thomas Hatch, and I'm also the Chief Technical Officer of SaltStack. Now, Salt is traditionally placed inside of the configuration management bucket, and rightfully so. It does a darn good job of configuration management. But Salt as a whole is many things. I originally built it as an automation platform, a more general purpose automation platform. My intent in building Salt was much more along the lines of being able to say that here is a platform that I can solve any distributed management problems I might run into with. So in all honesty, the first thing that I built with Salt wasn't configuration management. It was a project at the time I called Butter, which did cloud management. And it was a very, very thin, lightweight approach to managing clouds. Very, very thin. But why that is important in the discussion of Salt is because it helps us talk about the fact that Salt is a platform that you can build and express solutions on top of. The most common case solution for it is the automation of a data center. But subsequently, there are many single applications that you can use the toolkit for that go beyond simply managing and automating a data center. And that flexibility of the underlying platform is really what people stay excited about Salt for. When people get excited about Salt, it's because they say, oh, that's snappy and quick and that's useful. But when they come back to me 6 months down the road, they go, do you know what you have here? And I say, yeah, of course I know what I have here. And then they say something like, I built out a complete security management tool chain with Salt. And I say, how long did that take you? 3 weeks. What did you do? Oh, well, now we're using Salt to audit all of our file changes. We've got beacons that are telling us our active network connections, et cetera, et cetera, et cetera. We use Salt to audit and enforce all of our SSH access keys. And I'll ask them, are you using Salt to deploy apps? He says, yeah, sure. Of course. But so I want to talk about the platform that Salt is and how we get to the concept of an extensible management platform which can be molded into numerous specific tasks, and how SaltStack and SUSE are working towards delivering more of those specific tasks from a high-level perspective instead of just hoping that you've got a really good boffin who can do it for you. Now, Salt is broken up from a macro perspective into 4 things. Now, beyond those 4 things, there are many subsystems and components which facilitate these major 4 groups. But let me go over the groups first. the first and foremost and the foundation upon which SALT is built is a concept of remote execution. And SALT's remote execution is high speed and parallel, which allows you to communicate with large numbers of systems at breakneck speed. Another important aspect of SALT's remote execution is the idea that the minion is authoritative. So for those of you who may not be familiar sufficiently with SALT vernacular, we have a master, which is controlling and is the hub of authority, so to speak. And then we install a minion on all of the agents which we control. All right. So remote execution is the foundation, the ability to reach out to a system and in a normalized, predictable way, tell it to do something. Okay? Now I should mention, inside of SALT, and I'll go into this in a little more detail, as I said, minions, but more importantly, SALT at this point has the ability to work with an agent or without an agent. It has the ability to execute remote execution routines on systems which are more robust, like a server, and systems which are not, like, say, an old switch, or just a switch, or a hardware chassis, for instance. One of the demonstrations that we have over at the booth, for instance, right now is using SALT to directly manage hyper-converged hardware being produced by HP. All right, so remote execution, sure. The next thing is, again, what we're most known for, configuration management. So what actually is configuration management? If we look at the history of configuration management, the concept itself was originally really proposed in a paper published in 1993 by, oh my goodness, I just forgot his name. This is very embarrassing. The CF Engine guy. Thank you. Yes, Mark Burgess. Fantastic guy. Mark is just a wonderful, wonderful person. And so he defined the idea that the management of a system could be made significantly simpler and automated if we abstract away all of the differences inside of the system into an idempotent environment, okay? And so we have remote execution, and in SALT's remote execution, we ship with this huge library of functions, which give you direct access and control over a vast array of pieces of functionality inside of your infrastructure. This library of functions is really, it's SALT's standard lib. In it, it has numerous capabilities, and then upon which is where we put an idempotent interface to those same functions, which allows us to do configuration management. Yes?
So are all of the SALT functions, like those core functions, supposed to be idempotent, or are any of them not?
The core SALT functions are not.
So there's an idempotent interface on top of them?
Correct. Correct. And again, this goes back to one of my core principles of SALT, that managing an infrastructure, I don't think it can really be completely abstracted through an idempotent interface. There are times when you've just got to get something done. You need to just say, look, I just got to run this command out here, and I don't care if it's idempotent. There's a certain aspect of looking at the academic view of perfection and then saying, what is reality? Which is why Andrew Tannenbaum told Linus Torvalds that he would fail him when he came out with the Linux kernel. Because the Linux kernel, he said, we need something practical, not academically perfect. Otherwise, we'd all be running the herd. Now, this is a great audience. These jokes land. Okay. So this is one of those questions we get a lot inside of SALT, which is, hey, when are you going to merge your execution modules with your states? And we go, why would we do that? Because exactly, you have multiple interfaces that you need to work with when you're managing a system. But okay, so our configuration management system allows for idempotent abstraction of a system. But wait, there's more. Salt Cloud is a major component of Salt. Salt Cloud gives us similar abstractions over access to public and private clouds. And so those APIs become available inside of all of our functionality, okay? And, you know, lots of clouds. The general menagerie of clouds, which is kind of ridiculous, of course. Now, the last piece, and I think the crowning piece, and the piece where people usually start to panic, Aaron gave that absolutely stunning brief overview of SALT in the keynote on Tuesday. And someone from SUSE leaned over to me as he was getting to the event reactor system in SALT and said, "This has got to be where it all falls down. Like, it's not simple anymore." One of the core concepts of SALT is an event reactor system. And Aaron did a fantastic job of making it still simple, as he would explain that something happens on a triangle that changes it, and we can now magically react to that and tell it, no, be a triangle. So elegantly stated. But the event system inside of SALT, what's really going on under the hood is that all of the activity that's happening inside of SALT itself is being turned into events that are being fired back up to the SALT master and then can be parsed, redirected, reacted against, built into compound reactions, etc. We have some very powerful reactor systems inside of the master that allow you to do some rather ridiculous and fantastic things, whether they are ill-conceived for the sake of complication or not. All right. So, the event system. I should also mention about the event system that it can tie into and create events based on any arbitrary piece of functionality that exists inside of your infrastructure. And I'm going to talk about those individual components next. So these four macro components make up SALT, okay? The philosophy there being that with remote execution, or something I originally referred to as flow, plus configuration management, idempotent application of services, or as I like to refer to as state, the enforcement of the state of a system, plus an event system which allows us to view, manage, and react what's going on. And then we bring that together with the ability to integrate with things like clouds. And we have the ability to reach out, automate, and bring any aspect of an infrastructure, or frankly, digital deployment of any real type, as we'll see in the closing keynote tonight. I'm very excited about that demo. That even the Internet of Things is greatly assisted by SALT. All right. So that's all fine and good, but I also want to go over a lot of the cogs, the components and the pieces that are required to make all of these things happen. SALT itself is a very large system. It's approaching 1 million lines of code, and it is incredibly feature dense. So we have numerous subsystems inside of it. And so again, when people come and they say, yeah, good for config, they're only really scratching the surface. Okay? So let's talk about some of these components. Now, I mentioned earlier that we have a master and a minion architecture. So I'm going to start by going over that and expressing the components in that architecture. With that said, SALT is also built to have flexible topological architectures. So it's possible to roll out SALT without a master and to just have many minions. And it's also possible to roll out Salt with just a master and no minions, and to make everything agentless. But so we'll go through that a little bit. Now, on the agent or the minion, of course, because if you're not naming things creatively, then you're not having any fun in life, I suppose. On the minion, we have a number of systems which are very important. The first one I want to talk about is execution modules, which we have alluded to briefly. Execution modules are the one-off functionality that you have access to through Salt's remote execution system. So on the Salt master, we can run the Salt command. We issue a target. We tell it the function which we want to run, and then the arguments which are going to be sent to it. And then on that target, we send out that command in parallel at a ridiculous speed so that they are all able to execute at the same time. Okay? So, talking a little bit about modules. Again, this is a large library, but another thing that's very important is that this library automatically normalizes to the system upon which it is running. And so if it's running a really good target operating system and you tell it package.install, it knows to use Zipper. If you're running an operating system which is also good, it will know to run some other application. Okay? Similarly, it knows if you're running systemd, or if you're running Upstart or sysv, or you're on FreeBSD, it knows how to restart services. So again, that module system is very important through not only abstracting capability, but normalization. Okay? All right. The next thing that I want to talk about is grains. The question is, how do we know how to modulate or normalize against these relative systems? And so the concept of grains, so think of grains of salt. Again, I've been asked numerous times, whose fault is it that salt has silly terms? And I say, it's mine. Get over it. I think they're fantastic. And that is despite my best efforts to not be biased. So grains are information about the system. But it's a little more flexible than that. Grains are information about a minion generated on a minion. Okay? And they have a partner. And that would be the pillar. The pillar is information about a minion generated from the master. So this allows us to have a minion be self-declarative as to its own capabilities, but at the same time allows us to define a minion remotely without ever having to interface with it. Does that make sense? I see sufficient nodding to keep going. Okay. All right. Now, the next thing I want to talk about is targets. Traditionally, when we look at targeting systems and saying, hey, I need to run Command X on this group of systems, we would use a novel idea called host names. It's been around for a while. But inside of Salt, we extend that capability dramatically through the targeting system. What we're looking at right now is what we call a glob target, and it is based on basically host names. When a minion comes up, it assigns itself an ID, which by default is just the host name, but it can also be statically defined. And so we can target based on those host names using globular or regular expressions. Okay? But the target system also allows you to target machines based on where they are on the network. You can say, hey, everybody who is in this subnet. You can also say everybody who is running SLES 11. And you can say everybody who has a specific GPU, or everybody who has a specific CPU architecture. And you can statically set grains. So you can set a grain called roll, or whatever you want. Okay? So that targeting system is made to be as flexible as possible, so that under no circumstance And I feel confident in saying no circumstance because we haven't had to extend the target system for close to 3 years now. So for a while, we've been good on no circumstance, that you cannot successfully target the minions that you're trying to reach out to, okay? All right, so that's remote execution. And actually, that's also a lot about configuration management. I mentioned before the configuration management rests above those remote execution files, okay, in its own plugin system. And so you initiate configuration management via remote execution. But so the last thing I want to talk about with respect to this is the event system. And so we've got this concept. See, I've gone too far. My tether. We've got this concept called a beacon. I mentioned the event system about how everything that Salt does is abstracted into an event, and it goes on this event stream. But we have this system called beacons. And so with beacons, you can create a plugin which will watch whatever you want to watch, and then convert those into events and put them on Salt's event bus. And so and the other thing is that the event bus is open. So if you have sufficient privileges, say root privileges, on a minion system, and you would like to fire an event on the Salt bus from another application, then this is very easy to do. The best example I can currently think of is that very recently it was added to Zypper, that whenever you run Zypper, it fires an event on the Salt bus. So the master knows whenever someone is mucking about down there. Another good example of a beacon that we ship with is the shell beacon. If you activate the shell beacon inside of Salt, it will fire an event for every time someone executes a command on a shell, therefore sending you a complete log of every piece of shell activity which occurs inside of your infrastructure, which could plausibly be useful. Okay. The next thing I want to talk about, therefore, is the reactor. As all of the events are coming from the minions up into the Salt master, there is a reactor. And that reactor is able to listen to the events and say, a specific event has come in, and I have been configured to react to that specific event. That is the first reactor that we built, or the single event reactor. Okay? So, we're on the Salt master, and we react to an event. How can we react to an event? What are the options at our disposal? We're on the Salt master, so we can really do whatever we want to any system that we're attached to. It's incredibly expansive in that regard. We have full access to all of the remote execution systems, all of the configuration management systems, cloud systems, all of the IoT systems, etc. So it's completely open-ended as to how you can react from those events. It's very non-restrictive. Now that is the single event reactor. We recently introduced a compound event reactor, which was a little more complicated to get working, called the thorium reactor. All of you nuclear physicists might get the reference. I see one person laughing. Mission accomplished. Now the thorium reactor, instead of waiting for a single event to come in and react to it, it allows you to set up a model which says that the model says, I'm listening to a specific kind of event, and many of them are coming in. And as soon as a certain threshold with respect to that event is reached, then react. And so this makes it much easier to be able to say, that's one of those strong indicators where they say, just so you know, just so you know, you've been talking about this slide far too long. Have you ever given a presentation and had to type your password in front of a room of people and then typed your password into the wrong field because you don't see the screen? And I had to change that password. Okay. So, again, the thorium reactor allows us to now do things that are a lot easier along the lines of intelligent auto-scaling, and allows us to do things like detect as soon as a system hits a threshold which we have determined to say that system is no longer responding, I'm going to do something about that, as opposed to just waiting for that one magic event. Okay? All right. With that said, there's a couple other systems I want to go over really quickly. One of which is how the Salt remote execution works. When I originally wrote Salt, I used a queuing library called 0MQ, and used 0MQ as the mechanism to publish a command out to all of the minions. Now, if I want to publish a command out to a large set of targets, that command needs to be extremely small. And so I optimized it to fit in the smallest secure network packet I could come up with, which is effectively one cryptographic block. Okay? And so that's one of the reasons why the fan-out is so fast. Now, since then, we've built a native TCP socket system, which instead of relying on 0MQ's opinions about things, we also have the ability to use our now natively, purely built-in Python queuing system, which keeps up performance-wise just fine and has a lot more functionality into it. So we're very excited about that. But also, a few years ago, we introduced something called Salt SSH. So some people want to be able to manage their systems without having to install an agent. Understandable. This is certainly a valid use case, I suppose. And so we developed a system called Salt SSH, which allows Salt to function and do remote execution and configuration management, but without installing a minion. And it's significantly faster than similar SSH tools. About an order of magnitude is my definition of significant. Okay, so you've got a lot of options, is really what I'm going for here. Excuse me. A lot of options. Now, I'm gonna have to. I haven't talked about the mine. It's useful. Okay. No, I don't have all day. Okay, the next thing that's really important about Salt, and part of the reason, again, why it's very useful and achieves that original goal. The original goal, again, being a platform that we can solve specific problems with, as opposed to being a platform which precariously presents a single solution. To do that, we needed to make the system highly modular. Salt's architecture is built on a module system called the Salt Loader. The Salt Loader means that many aspects of Salt's systems are pluggable. And so even some of the most core functionality inside of Salt can be changed, updated, and modified very easily through this plugin system. Right now, Salt has over 25 plugin subsystems, which handle things from our newfangled thorium reactor to being able to build direct bridges into our file server system. So for instance, when you're running a configuration management routine and you have all of your Salt formulas that are available on the Salt file system, which has been optimized to pump out tiny files at a ridiculous pace, and you say, well, Wouldn't it be nice if I didn't have to copy all my files over to the SaltMaster and I could just grab them right out of Mercurial or SVN, or there's another one that's more popular, Git. And so that's just another plugin layer. This one, there we go. Yes. And so that pervasive modularity is one of the core aspects that makes Salt capable of wrapping any scenario. I mean, even when we go into an infrastructure and they're using Bazaar, that is plausibly handleable. We haven't had that problem yet. Okay, so this plugin architecture, again, is not only allows us to have that flexibility, but it also allows for the deployers to have that flexibility. In the demonstration tonight, they have created a Salt execution module, which is, again, just a plugin. And then they use Salt to deploy that plugin to all of the end systems which are being managed. I can't like give it away. They get mad at me. Or rather, I should say, I respect them. I'm not really afraid of Aaron. Now, how are we doing on time? I don't have a clock in here. All right, we're good. Okay. So, the next thing that I want to talk about is that now that we have this concept of open-ended management of systems, we need to talk about the expression of the solutions which are being built. When we want to build a targeted solution, which is going to solve a specific problem, as opposed to building an open source platform, then we need a mechanism to express that solution. And this is where the SaltStack Enterprise API, which was very recently released, comes into play. So, I talked about the fact that we've got minions that are connected up to Salt masters. But let's say that we want more than just running Salt's capabilities on a shell. Let's say that we want more than having all of your systems tied to a single master. Let's say that we want much more powerful role and access capabilities. Things that you generally need in enterprise management of systems. And so this is where the Enterprise API comes into play. How this Enterprise API works is that it too is completely pluggable. I'm kind of, better or worse, I'm kind of obsessed with the concept. It's worked rather well. And so how the Enterprise API works is that we've got a couple of things that we have to solve. First is whenever we're creating an infrastructure management system, it has to be highly available, right? Otherwise, you just say no. And so Salt masters have numerous high availability capabilities. Similarly, the Enterprise API out of the box is highly available, okay? And it's highly available in such a way that allows you to also spread the load. So that theoretically, it hasn't been out long enough for us to test this, theoretically it should be able to handle our largest Salt deployments. And that's something I should probably mention. That's usually actually a headline topic for us. So Mark's back there glaring at me. He missed this. He's being terrible. Sorry, Mark's the CEO. Yeah. Yeah, good job putting on the face for the crowd. He's fantastic. So one of the things that's really important to Salt is scalability. And that's why we have deployments that are in the many hundreds of thousands of servers. And why Salt's architecture is made to be scalable. So that we can do things like have Salt masters over numerous large groups of systems and then tie all of those together. so that you can use multiple systems not only to deal with physical scale, but also logical scale. As it is fairly uncommon, I say fairly uncommon, that you have a single block deployment which is managed in a unified way that has more than 10,000 servers on it. We certainly run into this scenario, but it's more of the edge case. And so it makes sense to be able to group out this master is over the production servers or the dev services, or this master is over this set of banking applications, and this one's over the Hadoop cluster, et cetera, okay? So we put a lot of effort into making sure that we have high availability, physical and logical scaling, okay? All right. So now I get to talk about the Enterprise API a little bit. And at that point, I will have basically waltzed through everything that we've got, apart from, you know, some of the little fun things like that cryptographic library I built. It's lots of fun. Now, or it's just a wrapper. Now, Enterprise API, how our enterprise offering works is that we have this Enterprise API server, okay, which functions somewhat similarly to a web app. And then all the masters tie up into these Enterprise API servers. And then they present a significantly robust API for managing Salt, okay? And then on top of that robust API, we've got a very nice JavaScript single-page app written in React, because we're cool as of last year. Apparently something else is cool now. I think it's called Aurelia or something. It looks cool. Now, or Angular 2, soon to be Angular 18. So, all right. So we've got a number of these pieces of functionality that exist up inside of this enterprise layer, where we're able to have things like much more advanced role-based and access security, tie-ins to Active Directory. We're able to aggregate all of the storage and filter out and manage the event stream that's coming in. So for instance, inside of the Salt master, we're getting huge amounts of data and events flowing into the master. And then, of course, we throw 99% of that away, because the Salt master doesn't come built in with a lot of those persistence and logging capabilities. Whereas the Enterprise API is able to target and store exactly what we need, okay? All right, and the Enterprise API and system comes back to the core. I just talked about that. Maybe I'm going to, there we go, that's more what I want. Maybe I'll go back again. But it comes to, excuse me, it comes to that original core premise, which wasn't, hey, I want to build a puppet-like thing, but it was, I want to build an automation platform that I can create targeted solutions that are reliable, robust, and scalable on top of that platform. But to achieve that, we had to build all the pieces from the ground up until we get up to the Enterprise API and the Enterprise UI. At that point, we get to the position where we were able to deliver highly targeted solutions to specific infrastructure problems and needs. And so what we're going to be talking about more in the coming months and years of SaltStack are along the lines of these targeted solutions being expressed. Because when we look at DevOps, and we look at configuration management, and we look at system orchestration and automation, those tools generally get to the point where they work, and you can say, yeah, I can automate some things. Great. and then they basically stop in their functionality. Whereas what we're able to now use inside of our Enterprise API and our enterprise systems is express highly specific solutions. And so one of the best examples of this that is shipping in the enterprise system right now is that Salt can be used for full CIS and STIGs compliance reports and auditing. But if you're doing that on the command line and tons of data is flying by, and manipulating those complex work cases is difficult. It's significantly easier to, of course, express an application like this graphically. And so that's why the Enterprise API comes with a preview of our CIS and STIGs compliance auditing and CVE scanning tools. So again, at that point, we're able to say, look, we can play in security auditing and management. And we already have a number of customers who have discarded other security auditing and management tools for just the preview version of the compliance auditing inside of SaltStack Enterprise. Okay? And so really what I guess coming back to that original premise, that is the goal of SaltStack. The goal of SaltStack is not to be the best config management player. Frankly, and I am biased, I think we're done. I think it is. I'm not worried about that. And are we continually making it better? Of course we are. But more importantly, SaltStack and the Salt software is about saying, we have a ridiculously robust and capable platform upon which we can now easily and smoothly express numerous targeted solutions. And then that pluggable nature is such which it becomes very easy for us to go into an infrastructure and go into a customer and say, what are the problems that you're facing? What are the reports that you need? What is the data that you need? What are the automation and reaction routines that you need? What types of systems do you need to configure, set up, and maintain? And now that and I admit it's taken us a little longer than we would have hoped, but now that we have the entire stack all the way up, we are able to solve those problems on the fly. It becomes that easy to solve complicated infrastructure management systems on the fly. And that fundamental premise of expansibility, modularity, and to be able to abstract the whole wide range of system functionality into a unified API that is normalized across systems, interfaces, hardware, and operating systems, and then present that in such a way which we can build those high-level applications, really is the culminating dream of SaltStack. All right. Whoop, oh, too far. I messed up. That one. Okay. So, perfect. So a couple of the things which we currently abstract, and this was one of the big problems that we ran into with making a UI for Salt, is it was the problem that Salt could do too many things. And so it became very challenging for us to say, okay, how much functionality do we actually need to express graphically to express a sufficient amount of Salt that that we can put this to market, right? And so at this point, the majority of what is expressed inside of our enterprise UI is the remote execution components of Salt, as well as the configuration management components of Salt. And we've also taken those concepts and then really beefed them up. So for instance, now you can easily put together targets, jobs, and states, which can then be made available at very granular permissions to specific users inside of your infrastructure, making it easy for that one smart guy to get stuff done, while the people who don't have the same level of expertise are able to push the right button on his behalf. Okay? And also things that we've been getting asked for a long time, like a complete audit history of every function that's being run inside of the infrastructure. Okay? All right. I think I have covered what I was hoping to cover. Does anyone have any questions, comments, arguments, rebuttals? Yes.
You mentioned the Salt SSH.
Yes.
Can you just 30 seconds more detail on that? Is that something you can modify the existing SSH out of box somewhere, or how does that work?
So the question being, Salt SSH, can you tell me more? So how Salt SSH works is that since we can't have an agent on the target system, Salt SSH creates something that we call the Salt Thin tarball, which is just the Python dependencies of Salt and Salt itself that we need to actually run the remote routines, packages up that thin tarball and SCPs it to a secure temporary location on the remote system, and then hits that remote system again, unravels it, and executes Salt on the target system. And then optionally, when you are done, it can automatically clean all of itself up so that there's no trace behind, or you can leave it there so the next time you run Salt SSH, it's significantly faster. But so we don't need to change anything about how SSH is configured and set up. Everything just wraps a normal old SSH connection. The way in which we maintain things like performance inside of Salt SSH is actually more philosophical and algorithmic with respect to managing the target systems, as opposed to being burdened by the fact that transferring over SSH is clearly transferring a lot more data than we have to if an agent is in place. And so Salt SSH, like Salt, works under this premise of the minion being authoritative for its own work. That makes it a lot easier to create very complex orchestrations which don't need to be done in a step-by-step manner. Instead, they can be done in a broad, idempotent sense, so that you can say, hey, everybody, start working on what you're working on, and the right systems will wait until they get signals from the other systems that they are ready. Okay? Also, over Salt SSH, we don't just expose configuration management. So the entire remote execution subsystem is also available. In fact, at this point, the only system or major component inside of Salt which doesn't exist inside of Salt SSH is the event reactor system. Because quite honestly, it's hard to manage arbitrary events when your entire communication with a system is isolated to SSH session compartments. But with that said, we do have, I don't know if I should call them plans or mere aspirations with respect to the architecture to actually facilitate the event system inside of Salt SSH as well. Is that what you were asking, or okay, probably too much. All right. Any other questions, comments, arguments, rebuttals? Have I done such a terrible job that we don't have any questions? Is there any other aspect of Salt which you want me to cover? I basically, we've got another 5 minutes. Yes?
I'm not sure this exactly related to this. I'm interested in SaltStack, and will SaltStack Enterprise integrate with SUSE Manager? Will the functionality be included in future version?
Oh, and this is something I definitely should have covered. I apologize. The question is SaltStack Enterprise integrating with SUSE Manager? And the answer is most definitely. SUSE Manager is a fantastic piece of software. Some of the main differences with SUSE Manager and Salt, there's definitely a little bit of overlap, although in a macro sense, we're going in different directions to solve also, again, it's very much about these targeted high-level solutions. How SUSE Manager works, and someone from SUSE, feel free to correct me. How SUSE Manager works is that it sits on a per master basis to manage its direct minions. And SUSE Manager is highly targeted and tuned to specifically manage SUSE and Red Hat operating systems. Now, Salt is made to manage any arbitrary operating system. So Salt itself can manage all major Linuxes and many minor Linuxes, if you're so inclined, as well as Windows, Solaris, AIX, and Mac OS, and FreeBSD and NetBSD, and nobody's paying us for OpenBSD, but I mean, the community says it works. It's about as far as we get for OpenBSD, and actually NetBSD. Okay, and so with all that said, the other thing that I should mention is that, so if we've got SUSE Manager enabled on a SaltMaster, and we've got the Enterprise API up here, and we do have customers that are doing this today, any activity which occurs inside of SUSE Manager still gets fired on Salt's core event bus up to the Enterprise API. So we still have a full record of everything that's happened inside of SUSE Manager up here. And similarly, SUSE Manager is able to track the records that, or I believe SUSE Manager is able to track what Salt Enterprise executes, because again, everything is just going through Salt's core system buses right on the master. And so SUSE Manager, so a lot of the messaging here is that when we're in environments that need management beyond just SUSE, SaltStack Enterprise is a fantastic solution. Also, when we're in a situation where we want to take multiple Salt masters and give a high-level overview picture, then SaltStack Enterprise also is an excellent partner to SUSE Manager. And it's also noteworthy that SUSE Manager ships with a number of pieces of functionality which SaltStack Enterprise isn't focused on, and vice versa. Does that answer your question? Any follow-on question?
No.
Okay. Thank you. Yes?
So your complex molecular view, I think you had some multi-master. What can you talk a little bit about the multi-master?
Okay, so the question is in my ridiculous slide. All right, fine. The question is in this slide which expressed the elegant complexity of Salt's inner workings. Is that better? Okay, thank you. No, that was much more praiseworthy. I appreciate that. There was a piece called Multi-Master. Was that about? Okay. Inside of Salt, we've got the master and minion architecture. But again, high availability is kind of a thing, as well as lateral scale. So we've got a concept called multi-master, where the minions are able to connect to multiple masters. Okay? In these scenarios, the minions can either connect to the multiple masters in one of two ways. And again, this depends on what you're going for. Okay? So we have a hot mechanism, which allows all the minions to be continuously hot connected to all masters, which means that there is zero failover time, because regardless of what master you connect to, it's going to work. Okay? We also have the failover master scenario. So the minions are going to be connected to either a primary master or arbitrarily randomly spread across those 3 masters. In that scenario, when you run a command, you want to run it on all masters because we've got an arbitrarily differentiated set of minions between each master, but if one master goes away, the minions will fail over to another one of the masters. Okay? So again, multiple scenarios to solve those specific problems depending on what they may be. Any other questions along those lines?